Excel Chapter 9, pages 526 through 530. Calculating the payback period of an investment. Open file name return from your Chapter 9 tutorial folder. Do a file save as and name it return analysis. And I think you learned how important it is to make sure that your file names are perfectly correct. All right, once you have done your file save as, click on the documentation tab, enter your name in B3, the date in B4, and you're ready to go on. All right, at the top of page 527, switch to the Building Project tab, and in cell B7, enter the formula equals B6 plus A6 equals B6 plus A6 equals B6 plus A6. In cell C7, enter the formula equals C6 plus B7. So this equals C6 plus B7 equals C6 plus B7. Copy the formula in cell C7 to the range D7 to F7. All right, this calculates the remaining cumulative net cash flow. Take a look at figure 9-24 and compare yours to what the textbook has. Then I want you to read about calculating net present value, the time value of money. Make sure you read all of that. And all of page 528, okay? Really important so that you can learn how to calculate the net present value, what it means, okay? And then read on 529 about choosing a rate of return. And once you've done all of that, and seriously, make sure you go do it, we'll start in the middle of page 529 to calculate the net present value of the building project in cell B10. Enter 12% for the desired rate of return. In cell B11, enter the formula equals NPV, and remember that's your tab key that selects those on those drop downs, equals NPV, and we want B10 and then B6 F6. And it did not like the way I entered this. That's okay, because I can go right back to it. And remember to put in my comma. That would help a lot, wouldn't it? Check it against my textbook, equals NPV, open paren, B10 comma, B6 to F6 close paren. And that made it a whole lot happier, didn't it? Little commas, little things like that are important. All right, that calculates the net present value using 12% as the rate of return and the anticipated returns from the project. All right, the formula returns $346,483, indicating that the present value of the project is worth $346,483 in current dollars. All right, in cell B12, which is net present value, enter the formula equals A6 plus B11 to combine the present value with the initial $300,000 cash expenditure in year 0 that pays for the project, which calculates the return from the initial investment. take a look at figure 9-25 and compare what you've got on your screen to what that little figure in the textbook, and make sure that everything matches. If it doesn't, you need to go back and find out where you made a mistake. On page 530, please read about understanding net present value and the NPV, net present value function. All right, to view the impact of different rates of return, change the value in cell B10. First of all, hit save just in case. Cell B10, it's currently at 12%. Let's change it to 9%. To decrease the desired rate of return, the net present value in cell B12 increases to 84,810, right there. The increase is due to the fact that the high returns in year 4 and year 5 are not discounted as much as they were at the 12% rate of return. Change the value in cell B10 to 15%. The net present value drops to 13,144. 13,144. There we go. Man, I cannot talk today. Let me see, because I don't like that. All right, change the value in cell B10 to 20%. To further increase the desired rate of return, the net present value drops to negative 33,501. Change the value in cell B10 back to 12%, which is Diane's desired rate of return for the expansion project. Reach up and hit your save. Go ahead and read about calculating the internal rate of return and using the IRR function, and you'll be ready to go on to your next video.